Example 11. Calculate the maturity value. That indicates that they want the total amount, the loan amount plus the interest. So the maturity value, we're talking about a loan here. This is the letter A, right? Of a simple interest 8-month loan of $8,000 if the interest rate is 9.75%. So let's think what we know. We know the initial loan amount was $8,000. We know that my annual, let me say that's really important, annual interest rate is 9.75%. So as a decimal, that's 0.0975. And then we need to look at our time here. Our time is 8 months, and again, it needs to match our rate. Our rate is always assumed annual, so that means our time needs to be annual. So what is 8 months? 8 months is 8/12ths of a year. So that's step 1. We've identified our variables. Let's go on to step 2. Now I'm going to be using the formula A equals P times, in parentheses, 1 plus RT. Well, in this case, step 3, let's go ahead and plug in those numbers that we know. This would be A equals P. Well, P is 8,000 times 1 plus, what's R? R is 0.0975 times T. T is 8/12ths. Close those parentheses. Be really, really careful plugging those into your calculator. Make sure you're using the parentheses or you will not get the right answer. And remember, this number here, the future amount, should always be more than the initial amount. Should always be more than the initial amount. So what are we getting? Plugging it into my calculator, I'm getting 8,520. Of course, that's measured in dollars. This is an amount measured in dollars. So how much do I owe? I owe $8,520. Is that reasonable? Absolutely. I would owe my $8,000 back plus an additional $520 in interest is what we're saying there. Okay. Do the same for example 12. Calculate the maturity value of a simple interest 9-month loan of $4,000 if the interest rate is 8.75%. Okay. So it wants the maturity value. It doesn't know what A is. It gives us our time. This is monthly. Again, we have to assume that it's in terms of annual. So time 9 months is 9/12ths of a year. Gives me my initial amount. That $4,000 is P. The initial loan amount. I know it's a loan because it's maturity value. And then I also have what R here is 0.0875. 8.75% annual, written as a decimal. That's step 1. I identified my variable. Step 2, I'm going to write out that formula. A equals P times 1 plus RT. Step 3, I'm going to plug in the numbers that I know. That would be A equals P is the $4,000 loan. 1 plus R, the interest rate is 0.0875. Times T, which as a year is 9/12ths of a year, and I close my parentheses. Plug this into your calculator. Be very, very careful. Let's see what you get. When I plug it into my calculator, I am getting, remember this should be more than $4,000. I'm getting an amount of $4,262.50. Again, I get 0.5, but if I'm writing my answer in terms of dollars, I either need no decimals or 2 decimals. So you can't just put 0.5. You don't have $0.5, you have 50 cents. So make sure you're using 2 decimals there. Is that amount realistic? Certainly. I loaned $4,000. I owe back just a little bit more than that. So that amount makes perfect sense to me. Let's go on to example 13. Calculate the maturity value of a simple interest 3-month loan of $3,800. The interest rate is 6%. Again, we have to assume that's annual. So they want to know the maturity value, that's A, of a simple interest. That tells me I'm using the A equals P times 1 plus RT formula. 3-month, again, this has to be in terms of years, so I'm going to say 3/12ths of a year. $3,800, that gives me my initial loan amount in this case. And because interest rate isn't labeled, we know that's in terms of years, so this is R equals 0.06. That's step 1, identifying my variables. Step 2, write that formula. A equals P times 1 plus RT. I plug in the numbers for step 3. Again, you have to show every single one of these steps. Step 3 would be plugging in the numbers. My loan amount, I was looking at the previous problem there, was $3,800. I have my 1 plus R, so parentheses 1 plus R, which was the 0.06, times the time, which is 3/12. Close those parentheses. Be very careful plugging that into your calculator. Make sure you're using your parentheses and do the fraction properly. I'm getting a total, again, it should be more than $3,800. I'm getting $3,857. So $3,857. Okay. Let's move on to example 14. Calculate the maturity value of a simple interest 1-year loan of $6,700. The interest rate is 8.9%. Maturity value, they want to know what is A. 1-year loan, well, this is in terms of years now, so I know T is equal to 1. $6,700, that's my loan amount or the initial amount, principal P. 8.9%, that gives me my rate of 0.089. Okay, that's step 1, identifying the variable. Step 2, let's identify that formula. It's going to be A equals P times 1 plus RT. Step 3, plug in what you know. I don't know A. P is the initial amount, $6,700. 1 plus R, which is the 0.089, times T, which in this case is simply just 1. Plug that into your calculator. Let's see what you get. I'm getting a total value of $7,296.30. Again, you must use 2 decimal places on that one. Round to 2 decimal places always. So $7,296.30. Let's do the last one on this page, example 15. Find the future value after 1 year of $850, an account earning 8.2% simple interest. Again, we must assume that that's an annual amount. Notice this is a little bit different in that it's future value. Future value here just to me means this is an investment versus a loan, but it's no different. We're still solving for A. 1 year, it's in terms of years, so that's T equals 1. $850 is my initial investment. 8.2% is my interest rate, so R equals 0.082. I've identified my variables. Let's write down that formula. A equals P times 1 plus RT. How much money would I have in this account? Well, let's plug in the numbers that we know. A would then equal P, which is the $850 you put in the account. 1 plus R, which is the interest rate of 0.082, times T, which is 1 for 1 year. Close those parentheses. Let's see what our calculator gives us. A equals, I'm getting a total amount, should be more than $850, and it is. I'm getting $919.70, rounding to the nearest cent. $919.70. Absolutely reasonable, just a little bit more than $850. So I just said absolutely reasonable, but I want to tell you that truly it's really not reasonable. Again, interest rates, if you go to a bank account, a savings account, you would never see an interest rate of 8.2%. And the previous problem, 8.9%. These are absolutely insane interest rates, okay? When you make an investment, you're looking usually at 0.01% for savings accounts and checking accounts. You might be able to get to 3%. You could see 8.2% if you invested in stock. But very, very rare, and that's very risky to invest in stock. We'll talk about that later in a couple sections. So these interest rates aren't too realistic for investments. Now for loans, those certainly are. When it says maturity value and it's a loan of 8.9%, a loan of 6%, those are very, very accurate. Like if you bought a used car, those would be very accurate interest rates at what you could get for buying a used car. So for loans, good interest rates. For investments, pretty much not accurate at all.